part actually less than 5, I just want to review radicals. So you could write this, like squish this in within this like warm-up section, but there's not really a great place to write it. This should also just be review, and you could just listen. A square root, like if I gave you the square root of 25, does anyone know what we would call the 25? No? Okay, that's okay. The whole thing we would call a root or a radical. The 25 specifically, you would call the radicand. I could, if I wanted to, put a little 2 right here. Do you guys remember that? But if I don't want to, that's also totally fine for the square root symbol. We assume if there's not a number there, it's a 2. That 2 we call our index. I'm going to do my own thing, so if you want to fill this in all within this like first page, go for it. I'm just going to, I have the space, so I'm going to write it to the side. The square root of 25 is what? Cool. The reasoning behind that, we would say because 5 times 5 brings us back to 25. Right? Nothing shocking should have happened in what I just said. If I gave you the cubic root of 8, our answer would be 2. Because 2 times 2 times 2 brings us back to 8. Does that make sense? Is that okay? Yeah? Do you guys know how to put cubic root into your calculator? Okay, let's take out our graphing calculators. So on your graphing calculator, if you press the math button, so below like your second and alpha keys, there's number 4 is the cubic root, and number 5 is the x root. So let's first look at the cubic root. So if you go down to number 4, press enter, and let's say we put in 27, then we get that the cubic root of 27 is 3. Say I wanted to take the 4th root of something. You first put your 4 down, and then you go back to math and go down to the x root. And then that like plugs the 4 in place of the x. And then if I said 81, let's say, we also get 3. So you always have to use just that math function on your calculators, that's all. We all know where just your general square root button is? On the left-hand side, below the x squared. Okay, cool. Back to our notes. So yesterday we learned about negative exponents. So now you've learned about positive exponents, negative exponents. Today what we're learning about is fractional exponents. So what your first page does in your workbook, I think is a very poor job of explaining it. But let's go back and say if I had 5 to the power of a half plus times, 5 to the power of a half, what would I do with those exponents? Add them. Good. What's a half plus a half? 1. So that would just be equal to 5. If you wanted to put that into your calculator, you just do 5 with the little up arrow, which is beside like your division symbol, and you can just put your fraction in there. And you get like some number. Five to the power of a half ends up being the same thing as the square root of 5. And the reason why is if I did the square root of 5 times the square root of 5, it gives me 2 point that whole number times 2 point that whole number, which just brings us back to 5. which is really kind of interesting. And it's this weird kind of thing. And remember, like, mathematicians made up what a square root is, and it kind of like extended into being the same property. So if you typed into your calculator right now 9 to the power of 1/2, you're going to get 3. Well, that's the same thing as just the square root of 9. Go ahead, Khalil. You couldn't. You couldn't really. And that's the weird thing, because what it's saying is 5 to the power of 1 is just 1/5. So it's like saying half of the value of 5, but within like multiplication. So that's where the square root portion comes in. And that's why it's the square root. So like your square root is your expanded version. That's a good question. So from this like premise, we can come up with this general rule, which is written on your page later on. But if I have a to the power of 1 over, what do they say? I think it's n. N. That's going to be the same thing as the nth root of your number. And it's kind of this weird like thing, and it is just how we can deal with fractional exponents. You can convert them to a radical or to a root, or you can deal with them as fractions. Depending on the question, what the question's asking for will determine the route you take. So let's go, I'm going to come to you. I want to go through a couple more questions so you guys can see this, and it's on like the bottom part of your page. So, for example, here where it says deduce the meaning for 2 to the power of, oh, just kidding, that's too low. Looking at these ones here, so part way down, 25 to the power of 1/2 would just be the square root of 25, which is what? 5. Same idea, 64 to the power of 1/3 becomes the cubic root of 64. So my denominator of the fraction becomes your index, or your root, what you're taking the root of. So cubic root of 64 is just 4. 81 to the power of 1/4 is going to become the 4th root of 81, which is 3. You can express these as well with variables, just like we've been doing before. So like x to the power of 1/2 is equivalent to the square root of x. By all means, you can just write like x, or you could write with the little 2 as your index. Go ahead, Claire. Like that you have like your check mark, the radical is there. Okay. Like just having that like root symbol makes it a radical. So that's a really good question. My apologies. So radical form just means that like that's there. B to the power of 1/3 would be cubic root of b. Go ahead, Sophia. Yep. Yep, everything's at play. And we will go through them all connecting together. So it's like building and building and building on things. Why you would ever take the 10th root of something, I honestly have no idea. But we could write it as to the power of 1/10 or the 10th root of p. Make sure in your printing you're actually putting like your index or your little number within the check mark. So if we had like on this example, it needs to be like a little 10 with the p, not 10 root p. So make sure you're writing your numbers smaller, because if you wrote it this way, that 10 then is actually a coefficient, which would mean I'm multiplying it then, right? How is that? It's kind of weird. It's kind of this weird premise of where it's coming from. But if you think of it as like exponents are repeated multiplication, and now I'm like taking it down to part of those numbers that we're repeating multiplying together. And that's why they're so connected that way. Where this like slightly becomes more difficult is you can have an exponent within your square roots. It sounds more difficult than it is. So, for example, if we look at their first example here, so they have the square root, of 5 cubed times the square root of 5 cubed. Anything times the root of itself times the root of itself is just going to bring us back to 5 cubed. Right? Like the square root of 25 times the square root of 25 is 5 times 5, which is just 25. I'm just going to leave it as 5 cubed. We can write this expression, so we can write the square root of 5 cubed as a fractional exponent of 2/3. And the reason why we can do it, if I was to add those exponents, I would get 3 over 2 plus 3 over 2, which gives me 6 over 2. 6 over 2 I can reduce to 5/3. Is that okay? Does that make sense? So it's like when I gave you like my little story about this guy making up exponents, and then his buddy coming along and being like, what's a 0 exponent then? It's like a third buddy came along and was like, hey, what happens if we have fractions? So then they started playing with those fractions and were like, oh, that's the same thing that happens if we have a square root involved. Go ahead, Khalil. I have no idea. No clue. I'm sure Google can tell you. Fair question. Let's not Google it right now. That's a whole rabbit hole you'll go down. So let's look at this overall premise that they're getting at. Our general rule would be that if I have a number to a fraction, I can rewrite it actually using 2 different ways. So it can be the nth root of a to the power of m like that. Or you could write it to the all to your power of m like that. You're actually going to get the exact same answer in both of those cases. And I will go over an example with that for you. Like it doesn't matter where you put your exponent in. So let's say I had 8 to the power of 2/3. I can rewrite that as the cubic root of 8 squared, which, what is 8 squared? 64. I take the cubic root of 64, and I get 4. Or you could think of it as the cubic root of 8, that answer being squared. Cubic root of 8 is 2. 2 squared is 4. Both ways, you're always going to get the same answer. Both ways are equally correct. For whatever reason, and I genuinely don't know why, I almost always like it this way better. I find my numbers are smaller, my mind just works better for it. That is personal preference. Situational, one might be slightly better than the other, but they both will always be correct. So let's look at these examples at the very bottom of this page. So if I have x to the power of 5/3, my 3 becomes the little number, and I get x to the power of 5. B to the power of 4/5. Denominator becomes the little number, or my index, b to the power of 4. P to the power of 5/2. 2 is my little number. P, and then, like I said, you could put it in brackets with the 5 on the outside like that if you wanted. turn your page. I'm going to skip their next couple of warm-ups. Here they've written out your general rules for you again. So I've written those out separately for you, but they do have them in here. Okay, let's look at their class example 1 and go through all of these. So, solve these without a calculator, they say. These are all numbers I think we should be able to do in our heads. 25 to the power of 3 over 2. So this is going to be equal to the square root of 25. That answer, cubed. What's the square root of 25? 5. What is 5 cubed? Fabulous. That's a number I think you could do on your own. I would hope. And if you can't, you could figure it out on your own. 1,000 to the power of 4/3. So this is going to become the cubic root of 1,000. And then that answer to the power of 4. Cubic root of 1,000 is just 10. 10 to the power of 4 gives us 10,000. Slightly trickier, so this is where we're starting to combine some rules. I now have a negative fraction. Let's make it positive. Life is easier with positive, so let's make it positive. So this is from yesterday's class. So my first step is going to be to rewrite it as 1 over 27 to the power of 2/3. So I have to move it to my denominator. Now it's happy. My exponent's positive. So now I can deal with that fractional exponent. So that's going to become the cubic root of 27. And then that answer is squared. Cubic root of 27 is 3. 3 squared is 9. So you just get 1 9. So it looks really scary and intimidating and ends up being a little bit simpler. I'm going to skip 16 because that's like the same thing. Let's look at E and F. What's the only difference between E and F? Brackets. You have to be very careful with brackets. So in E, I have brackets, so my negative is included. So when you rewrite E, it's going to become the cubic root of -8. That answer squared. Cubic root of -8 is -2. -2 times -2 gives us a positive 4. On F, I would think of this as really saying -1 times 8 to the power of 2/3. Because that negative is not included in the exponent, and by rewriting it like this with the 1, it's kind of a placeholder for your mind not to like get tricked into including it. So when I rewrite this, I get -1 times the cubic root of 8. Then I have to square that. So I get -1 times 2 squared. I'm showing a lot of steps here. You guys could show less. But 2 squared is 4, so then I get -1 times 4, which gives us -4. By doing that -1 out front, it really kind of helps you. Okay, this last one, G, can I just apply that 1/2 to my 2 terms? Like multiply it in? No. Why not? That's a really good idea. But no. They're separated by addition. So we have to deal with our addition first. They're separated by multiplication. Well, my exponent is multiplication, so the order doesn't matter then. But according to our order of operations, we have to do our addition first. So I'm going to do actually exponents and then add them first. So I'm going to go 9 plus 16. and then I'll deal with that. So 9 plus 16 gives us 25. 25 to the power of a half is just the square root of 25, which is 5. Quentin, return to me. Let's write something down. Okay, let's go over class example 2. So turn your page. What's the difference between these two? Good. First one has is positive, my second one has a negative. So when I have a fraction to the power of a fraction, my exponent's just going to go to both of them. So you could think of this one, and this is how I would encourage you to do it, is really saying 9 to the power of 3 over 2 and 4 to the power of 3 over 2. So then it's the square root of 9 to the power of 3 over the square root of 4 to the power of 3. Square root of 9 is what? 3. So then I get 3 cubed over 2 cubed, which gives me 27 over 8. Yesterday, the very last rule that we talked about was if you have a negative fraction, in order to make this guy positive, I can just reciprocate the inside. So I could rewrite this as 4 over 9 all to the power of 3 over 2. And then my exponent's positive. And you continue throughout this the same way. Go ahead, Khalil. So, like, why I can just flip it? Because what's going to happen is I would apply, I'm not going to go through expanding this one out, but so this is like coming back from yesterday's lesson. So this would be equivalent to 9 to the power of 3 over 2 over 4 to the power of 3 over 2. And then I would have to move them each to make the exponent positive.
If you have a negative fraction you just flip it again and it's positive.
No, only works with exponents, the flipping with negatives. And that's why it's so easy to like make mistakes. If you have a negative like base or your number is negative, it just sticks with that number. Flipping it only works with exponents. It's tricky. There's a lot of little nuances in this unit. Okay, that's all I'm going to say for today. It's a lot. I know that's a lot to take in. Okay, so for your practice questions, I'm changing the ones posted. I don't want you to do 5. 6, that's an I to L. It keeps making a capital I. So it's just like the very last row of number 6. And then yeah, we will go outside. I want you to do 7 and 8 though. This stuff is tricky. So what we're learning tomorrow is like continuing this. It's not that it gets that like harder. It's just like different types of questions within this stuff. But this is very much hard. Like I get that this is a lot to take in.